Hello, Tom from Every Step Calculus, everystepphysics.com. This is a Newton's method for approximation problem, and this problem here was written down by Patrick JMT, one of the best teachers on the internet for students, in my opinion. Anyways, I wanted to show you how my programs work on this. Remember, my programs are in a Texas Instrument TI89 Calculator, where you can take into your class, bring it out of your purse or your school bag or whatever, and solve these problems in class, okay? Whereby Patrick JMT, you got to learn it, and this would take you about a week to learn this problem here, to be able to do it from a test problem or homework or something. As with a lot of these calculus problems are extremely difficult to learn. That's the reason I programmed and started programming it, because I wanted to have it for the rest of my life and have it in the calculator, which I could do. Okay, so let's do it. Index 8 to get to my main menu. I'm already at Newton's method. You can see this right here. Save time. And here's the formula. You always want to write the formula down on your test papers right away, because then you certainly got 2 more points or 3 points just by the formula itself, memorizing this. As usual, n is the number of times you're doing something in approximation or series, Taylor series, things like that. And we're going to enter the function. Okay, so you have to press alpha first, and this is a 7 up here, x to the 7. You can see it here, x to the 7 minus 1,000. So we're going to have x to the 7th power minus 1,000. And I always show you what you've entered so you can change it in case you made a mistake. I say it's okay. And what do they give you here? Well, they give you 8 decimal places. And we're going to use, like Patrick here, we're going to use number 3. So we're going to use number 3 here, or let's do it. Yeah, we can do it. x1 equals 3. Okay, we're going to press 3. You can press the numbers before the thing, or scroll to it. Press alpha and 3. How many decimal places? They want 8. Alpha 8. Okay, so here we have x1 is 3. Generally they started at x equals 0, x sub 0, but this one is x1, and x1 becomes x2 for the calculation. So x2 is equal to 3. And then according to the formula, we determine f of xn. Here's f of xn up here in the numerator. And then I show you the function. Here's x7 to minus 1,000, and then we enter the 3 for x. Okay, so here's 3 to the 7 minus 1,000. And so f of xn equals 1187. Okay. These, because of the calculator, I have to put quotation marks around this, but on your paper you'd put parentheses, okay, where you're entering a substitution term here. And then we're going to determine f prime of xn, which is the denominator. Here's xn here, right, which is 3. And so f prime, derivative of the x7 minus 1,000 is f to the 6th power, x to the 6th power, okay? So now we add the 3 in here for x, the 6, we come up with 5103. We put this together, 3 minus 1187 over 5103, and equals minus 60827, and then the answer is x2 is 2.7673917. Okay, so we press enter again. Now we're going to take x3 and make it, or x2 and make it x3. Okay, so here we're going to substitute this in here now for the new system. So we're entering the new system here, minus 1,000. That turns out to be 243. And f of x1 is equal to 3144.28. We do the calculations here. Turns out to be 2.6900874. So now Patrick has done this x3 before this screen here. Let's do x4. I'll do it quicker here. Of course, you write all this on your paper, you know. So x4 is equal to 2.6827564, which is what he has here. Okay. The idea is that you keep approximating these terms, adding them into the formula here, and it keeps approximating to get it closer to what the actual x-axis is between 2 and 3 here. Remember, we use 3 here for the approximation. And x5, we do the calculations. Turns out to be 2.6826958 right here. Now we do 6. $2.6826958. No more nonsense. Remember, calculus solves nothing useful in my opinion. I've always bitched about calculus. It's a waste of time, total waste of time. It's never been used in anything. And the reason for that is because it needs a function, and somebody has to dream up the function, and there's no class for designing the functions. Even here you have x to the 7 minus 1,000. Who dreamt that up? I mean, it's not a real function. You can graph it. And of course it's like this right here. Actually, when you graph it, it comes up and goes closer to the x-axis and then up. But that's all calculus does, okay? So anyways, go to my site, buy my programs, and pass calculus if you want to pass it. Otherwise, you can suffer like I do. And the program, this took me about a week to do it. And then, of course, you have to figure out what they're doing and how they do it. So I have to go online and see all kinds of problems where people are answering things to get the consensus of how to do a problem. And why would you program something that isn't kind of perfect, you know, kind of like exactly the way it should be, you know? Because once you buy these programs, you'll never get rid of it. You can throw your calculus book in the trash, but never throw this in the trash, because you'll always be able to do calculus with my programs in this calculator. And they're good instructions, easy to load, takes time. There's over 500 programs that I've designed just for this. And of course, don't forget about physics. Physics is a demanding subject, and you certainly need the calculator in my programs for physics. So keep that in mind. Go to my site, buy my programs, and pass calculus or physics. Hey, have a good one. Hey, if you feel like it, you can subscribe to or share it with somebody, you know, this video. Never hurts to do that. Have a good one.